All right, this is another self-quiz video. In this video, we're going to do a method of initial rates problem. All right, so you're given a reaction and some experimental data, including the initial rates for 3 different setups of initial concentrations. And the goal here is determine the rate law for this reaction, including the value and units of the rate constant K. All right? I'm going to give you a hint here in just a moment. If you don't feel you need the hint, go ahead and pause the video and try to work the problem. If you need the hint, stay on, and I'll give that to you now. So remember that when we do these, we're going to start by writing a generic rate law. The generic rate law is just going to be the rate equals the rate constant K times the concentration of each of the reactants. We've got 2 reactants here, Cl2 and O3. We've got the Cl2, we're going to raise that to the A power because these always have an order or an exponent here, times O3 concentration to the B power, or the order with respect to O3. So that's, remember then you're going to take these values up here in the table and plug those in, try to get some things to cancel out. Hopefully that is a good hint for you. Go ahead and pause the video and work the problem. All right, here's the solution, and these are pretty time consuming. But once you get the hang of them, they're really pretty straightforward. All right, so we're going to take our generic rate law. We're going to plug in. I'm going to plug in experiments 1 and 2 because I notice that the O3 concentration doesn't change between experiments 1 and 2, which means that the O3 term is going to cancel out, making this a lot easier. So we've got rate equals K times, let's stick to the same order here. Rate times Cl2 initial it's just concentration. I don't know what I'm doing here. Here we go. To the A times O3 to the B. And I'm plug in experiment 1, 0.130 millimolar per second equals K times 0.010 molar to the A times 0.010 molar to the B. Now experiment 2, which I'm going to divide into here, 0.521 millimolar per second equals rate constant K times 0.040 molar to the A times 0.010 molar to the B. So we notice that a number of things cancel. Millimolar per seconds cancel. Rate constants cancel. We also get 0.01 molar to the B over 0.01 molar to the B, so that cancels. The only thing I'm left with are the rate values here and my A terms, my Cl2 terms. So I'm now going to divide. You can, when you plug this into your calculator, it'll give you about 0.25. I like to leave that as a fourth. I think it's easier to see. If you prefer 0.25, it's fine. Equals, now I'm going to have 0.010 molar to the A over 0.040 molar to the A. And I'm going to simplify that by stating that that's 0.010 molar over 0.040 molar. That's all raised to the A power. All right. 0.01 over 0.04 is 1/4. So I've got 1/4 equals 1/4 to the A. And by inspection, I see that A has to be 1. Remember that in this course, we're going to confine ourselves to A being 0, 1, or 2. And so the only number that makes sense there is 1. All right. So that gives us our A value. We're going to do this again to find the B value, our order with respect to O3. For that one, which one am I going to do? I'm going to do experiment 1 and 3 because I see that the Cl2 term won't change. You could plug in 2 and 3 here and plug in the value of A in, and some folks like to do it that way. I find it better to do it this way in case I've made a mistake finding the A value. So I'm going to plug in 1 and 3. So that's going to be 0.30 millimolar per second equals K times 0.010 molar to the A times 0.010 molar to the B. And that's going to be divided by, let's see, what is this one? 1 and 3, 0.259 millimolar per second equals K times, should have written a little smaller, 0.010 molar to the A times 0.020 molar to the B. So units cancel, K's cancel, chlorine terms cancel. Plugging this left-hand side in, you get about 0.5 or 1/2, and that's going to be equal to 1/2 to the B. So B is 1. So both orders are 1 here, right? So now we're most of the way home. We've got our orders. So we know now that the rate law is going to be rate equals K Cl2 to the first power O3 to the first power. And if you wanted to leave those powers off because ones are understood, that's fine too. Now we got to find the value of K. So the way you find the value of K is you plug any one of the experiments in, and then you solve for K. I'm going to choose that first one. I've kind of got that number memorized now. 0.0. There's also lots of 0.01s here. That always makes it easier. All right. I'm going to simplify my right-hand side. Bring this down. So this is going to be 1.0 times 10 to the minus 4. Now remember, your molars are multiplied too. So a lot of times people here will drop those because they're not paying attention. You've got 2 molars, they're multiplied by each other. That's molar squared, right? So now we've got this interesting problem where over here I've got millimolar and over here I've got molar, and that's going to cause a lot of problems. So you need to get these in the same unit. I think the easier thing to do here is just off to the side, change millimolar into molar. So remember, there'd be 1,000 millimeters in a meter. So there'd be 1,000 millimolar in 1 molar. Okay. So yes, you have to remember how to do units from first semester. So that cancels out, leaves in molar. And that comes out to be 1.30 times 10 to the minus 4 molar. Okay. So now back over here on my actual problem, 10 to the minus 4, that's molar per second. I'm going to bring that per second up to the numerator and make that seconds to the minus 1. We've done that a number of times, but the sooner you get comfortable with that, the easier this makes it. So molar squared. Now I got to isolate K by dividing both sides by 1.0 times 10 to the minus 4 molar squared. Okay, so this cancels out. I'm left with K over here. The numerical part of this is pretty easy because you've got 2 10 to the minus 4s. So this comes out to be 1.30. The units are a little trickier. So you've got molar times seconds to the minus 1 over molar squared. So I'm going to remind you here of a little algebra that you may have forgotten from, 9th grade. If you have x to the a over x to the b, that's the same as x to the a times x to the minus b, because when you bring something from the denominator up to the numerator, that switches the sign of the exponent. When you have terms that have the same variable but different exponents, you can add those. This is x to the a minus b. So you can shortcut this if you like by saying, oh, I have x to the a over x to the b. That's the same as x to the a minus b. Whichever of these two ways makes more sense in your head, you do it that way, all right? I like the shortcut because I'm lazy. So also I do this every year, so I don't forget this. But like I said, do it how you want. If you do this the long way, it's molar to the first power times molar to the minus 2 power times seconds to the minus 1. Molar to the 1 minus 2. 1 minus 2 is negative 1. Again, you could have just done up here 1 minus 2 gives you minus 1. Okay. So that's our value and units for K. All right, so reviewing the whole darn process, You're given these initial values and initial rates. You create a generic rate law. You plug in, get things to cancel out, determine your orders here, plug those back into your generic rate law, solve for K, pay close attention to your units. This is one of those places where I know that a lot of times you all like to memorize what the units need to be, and this is not one of those times you can do that. You have to plug the units in. You have to carry them forward. You have to see how they work out. You have to do some algebra, okay? Make sure that you do lots of practice on these. Make sure you've done every exercise and homework problem that you may have skipped on these, and shoot me any questions. Thanks.